Okay, well, hello. My name's Samuel Davidson. I'm a software engineer at Google. I work on Google Kubernetes engine on one of the security teams. Kubernetes, as well as GKE, is a big Go microservices platform, and we use a ton of gRPC, and we use and pretty much everything everywhere has context, the context object, as the first parameter in all our functions. And as an engineer on all these microservices for years, I've just been kind of, I don't know, copy pasting, not really understanding what this object was until a few months ago. And I was like, you know, I'm going to make a little talk on it. I'm going to figure it out, get a little talk internally to my team. They liked it a lot. It got shared around, and so I got invited to give this talk. So that's the background. It's a sort of internal talk I've taken apart. I gave it at GopherCon EU a couple weeks ago, and that was pleasant. So Sam B. Davidson @ is my Twitter handle. I don't check that Twitter very much, but you can also DM me on LinkedIn, and I'm more responsive there if you want to connect or chat or whatever. So the name of this talk is Context is Key, the context.Context object that everyone's passing around. So the format of this talk, 3 parts. I'll try and go quick. First is the design of the context object, the actual sort of philosophy behind it. The second is the API of the package and how you actually use it in Go code. And third are just a bunch of useful usage patterns, certainly not exhaustive, but stuff you might recognize or find interesting. So first section, the design of the context object. So just to clarify, if you don't know what this talk is about and you're already lost, we're talking about the package called context that's imported as such. You may have seen CTX abbreviated as a variable, or you may have seen it as the first parameter in some RPC function. That's what I'm talking about. So it's a very common package used in all the biggest, it's ubiquitous among Go. It's used in all the big packages. In Go, 15% of all Go files import it. gRPC 34%, Kubernetes, FTP, Terraform, very common. And it's especially common in sort of the front end API, that sort of layer that you talk to, the sort of public layer of the package, net HTTP, gRPC, database SQL. It's very common as sort of something you can attach to requests or put as the first parameter. But if you were like me, as I described at the beginning, I'd be hacking away, you know, providing immense value to my employer, and I come across some subquery, some function that takes context as the first parameter. I really don't know what it's supposed to do or what it is, but hey, of course, it's also in the surrounding function. Oh, I'll just copy paste. Yeah, works fine. It compiles fine. Nothing. No one yells at me. And this is kind of how I got along for years, essentially. Or maybe worst case, I call context.background and just get a new one in some test, and nothing yells at me, and I just hope. But what is this object, right? So it's used for Go routines and RPCs, as you've probably seen in your own code bases. It's a simple state container of 3 things. First is the cancellation status of this Go routine or RPC, the timeout associated with this Go routine or RPC, and any sort of arbitrary key value pairs that are important for this request, sort of at a metadata level. So let's look at a sample. This context object has the cancellation status of false. It's a Boolean. So this RPC isn't canceled. It's got a timeout about 30 seconds from now, at which point it will automatically be canceled. And it's got some key value pairs, maybe a request ID, some generated ID used for logging maybe, and a big credential jot that will represent with a little piece of paper with my name on it. Okay? And the last thing about context is when you make one, you can also get a cancel function, which is a function you can store in a separate variable that when you call, it takes no parameters. When you call this function, it will automatically mark whatever context it's associated with as canceled. And that may seem really strange and not make any sense to you, but we'll explain it in a minute. So as I said, contexts are passed around RPCs. So I've got my PC, I come up to it, you know, and I type in the command line, my app query database. This is a pretend app called my app that uses gRPC and contexts. And the first thing my PC would do is create a context object locally. It would maybe assign whatever timeout I'm willing to tolerate by default, maybe 30 seconds. It would attach some local credentials that validate me as Sam, as Sam's PC. And then it would send that request with any request parameters or whatever with the query, as well as the context object onto the network stack. So maybe it's a load balancer first, that gets forwarded to a front end. The front end forwards just the context to an auth server that could extract out the credentials and validate who I am, validate I have permissions, move on to the back end, the database, et cetera. And the value of the context being passed all over the place like this is that all of these different computers and subroutines and RPCs all know that they're handling really one request. It's not a whole bunch of unrelated requests. It's all one context, right? It's by Sam, and it's timing out in 30 seconds. And that sort of context can be also wrapped into print statements. There's all kinds of loggers that take context objects, and you could maybe print that detail and be like, okay, these requests are erroring out as part of a common, every request Sam makes errors out. Maybe we can debug that specifically. So taking the same network stack in a more simplified view, we can explore all the different parts of a context object, starting with the timeout. So when Sam's PC sets a 30-second timeout for the original context that it's PC, all of these context objects in all of the RPCs will say that their timeout is 30 seconds, because that's from the sort of root context. But sub requests that are getting with a context can have things like the timeout overwritten. So the front end to auth server request could have only a 5-second timeout that the front end sets to it. And then maybe if 5 seconds expires, it retries, and we can try a few times at the auth server within our 30-second window. I don't know, something like that, right? Similarly, the load balancer could put a shorter timeout to the request to this front end. And if that 10 seconds expires, this context, as well as any sub requests based off that context, will expire. They'll be marked as canceled. These computers can stop working. And then maybe the load balancer could retry on a different front end. And let's just say another 20 seconds passes. This fails again and again. Then the original 30 seconds from Sam's PC will expire. All child requests from that original context will also be marked as canceled. And they all know that at that point they can be listening, that their context is canceled, and they can stop working free of resources, because Sam's PC has now reported to the user, request timed out, and we don't care about the response anymore. Okay, let's dig into key value pairs. So key value pairs are pretty much exactly what they sound like. There's a key, in this case, this string creds. Again, it's just a toy example, and it points to some blob, which is my identity. That will automatically be sort of copied and pasted all over with all of these contexts over the wire. They all have access to the creds variable, right? And you can do this for a whole bunch of different things. Similarly, you could maybe build out a trace key value. So the key is trace, and the value is, whatever computer this context went through, or whatever machine this context has visited. So let's say all of these computers sort of implement the same library that will overwrite the trace value with, the current trace value and their own PC names. The load balancer adds its load balancer Seattle, and then the front end could add the front end machine ID, and the back end could add its own back end ID to these to this same trace key value pair. And then if, let's say, an error occurs in the database, we could have, again, some special print function that extracts out the trace key value pair and puts it as part of maybe a log statement, help people debug. They could see that traces that this request failed as part of this stack of VMs or something, and that can make debugging easier. And this is actually how tracing is implemented. There's a lot of open source tracing libraries that trace through embedding metadata in the context object, which is pretty cool. Another interesting thing you can do with key values is, obviously, these sub requests can have different unique keys and values added to them. So the front end could add its own credentials to the context object sent to the auth server, so the auth server can trust, I'm talking to a valid front end. Maybe the back end is locked down, so only trusted back ends with valid credentials can query the database, because we don't want the database accessible to everybody, stuff like that. Key value pairs, super flexible. They're literally like any type to any type, key and value. So you can put request IDs, experiment IDs, platform data, timestamps, versions, whatever you can think of. And you might be thinking they're very flexible, which they are, but because again, they're just any type to any type, but you could run some risks by just putting too much crap in there. So what if you put your request parameter in there and you start just using the context object as this generic bucket to store any data relevant to any variety of requests? Start putting your username, query ID, I don't know, put an image in there, put the bytes of an image, put page numbers, query time, results limits, parameters, whatever. It's a bad idea. When I gave this talk to the context devs a while back to have them sort of proofread it, they wanted me to add a slide about this because I think people misuse the key value pairs a lot and just put too much junk in there. And you shouldn't use the context as an arbitrary key value store. It should really just be for like metadata that spans the entire request across any number of RPCs. Again, use the context values for only request scope data that transits processes and API boundaries. Why? There's a bunch of reasons, some of which are it's just messy. You lose your type safety. It just becomes blobs of data that you have to, at every machine, parse out and extract and cast different types. You don't actually have good visibility into the keys and values within a context object, which we'll explore later. And most importantly, if you're a rule follower, the context docs say don't do it. So the last thing I want to touch on in this section is the cancel function. I described it as sort of this magic function you get with a context object that when you call the function, it will automatically mark it. The context is canceled, no matter what the timeout is. So in this case, when SAMSPC creates its context object, it also gets a cancel function represented by this TNT here. And if I came along and I was like, wait, I don't want to make this big long request, I hit, Control-C, sigterm. My PC could hypothetically pick up on that, call the cancel function before terminating, which would automatically over the wire mark all of these contexts as canceled and just propagate to all sub-requests that are currently going on using the context derived from this original context. And this is useful because it informs all those PCs that I don't care about the response anymore. You can free up resources, stop working, stuff like that. You could do something like this where the load balancer is trying to be really snappy, so it sends a whole bunch of parallel requests to a whole bunch of different front ends, returns whichever one is fastest first, right? So let's say the bottom one returns first. It could cancel the upper request. It could cancel all other siblings and just return to the user the one that finished first. And then all of those other front ends can clean up resources and stop working. So naturally, based on how they sort of branch out with requests, the context objects form a tree where you've got, my PC at the root, potentially SAMSPC, and then it's a load balancer, which could talk to multiple front ends, auth servers, backends, databases, et cetera, forms the tree structure. This is important because timeouts and values, cancellation status all propagate downward the tree. Instead, it's unidirectional. So this whole tree has a 30-second timeout. But if this node were to be updated with a 10-second timeout, then all of its children would have the 10-second timeout rather than the 30 seconds. And if they expire, only this node and its children expire. Similarly, if you were to get a cancel function for a sub-context and cancel that context, only itself and its children would expire or be marked as canceled. And that'll make more sense when you dig into the implementation in a moment. The importance of this unidirectional tree is that you can't sort of request down the tree, context down the tree can't attempt to make changes to things up the request tree. So this maybe some request way down the tree thinks we need more time. Can we extend the timeout, please? You can't do that. Timeout is set at the root or at your parent level. You can't affect it. You can only affect your children's timeouts and values. And similarly, you can't tell the sibling to you can't tell other contexts, I want you all canceled. You have to be the parent owning the cancel function to cancel child contexts. So design-wise, that's the whole design. That's sort of how data, cancellation status, timeout, keys, values all propagate across an RPC ecosystem to downstream RPCs. So normally I'd take questions, but I'm trying to hurry. We'll just save your questions for the end. I'm sure some of you are very confused, but I'm going to move on to the API and how you actually use this in Go. So the API of the context package. The API of the context package is actually super duper simple. So when you pass one of those context objects as your first parameter, there are only 4 functions you can do on that context object. Well, it's an interface. There's actually a bunch of implementations behind the scenes, but it's an interface and it's got 4 functions. A done function, which is a channel, which returns a struct. What that will do is either hang indefinitely until the context is canceled, or it will be closed with a nil value. Those are the only two things that could possibly happen with this function. So it'll really only ever return nil with closed. And this is how you can kind of indefinitely wait for this context to be canceled. There's an error that will either return nil if this context is not canceled. It will return context canceled if the context was canceled via a cancel function, or it will return context.Deadline exceeded if the context is canceled via a deadline timeout. And those are the only three things it could ever return. Deadline, it will return either true for the OK with a deadline, or it's possible for context just to not have a deadline, so they don't time out on their own, in which case it would return false and nil. And then the last function is a key value lookup, where you can pass it the key that you want to look up, and it'll either return the value of an untyped interface that you have to cast, or it'll return nil. And that's it. It's only 4 functions. Really simple, very consistent return objects. But you might be left with some questions based on what I told you in the last section, which is like, how do I cancel this? I thought there was a cancel function. How do I shorten the deadline like you showed me I could, or add values, modify the key value pairs? I'll explain that in a moment. But the important thing to know about contexts, which explains why it's so simple, is that they're all actually immutable. You can't cancel them. You can't like modify them, mark them as canceled. You can't change their keys and values. The way you modify a context is by bundling it up as a brand new context and wrapping up the old one as a parent. So you can kind of think about every context object that has a whole bunch of stuff going on inside it is actually a whole bunch of context objects all duct taped together with changes, with the change you want. With a shorter timeout, you take a context with a longer timeout and you duct tape it with a shorter timeout, and you get a brand new context object. So I like to think of nested boxes where the innermost box is the oldest and the outermost box is the latest creation of a context object. So we'll go into explaining that a little bit more. So we have our context object sort of discussed at the beginning, which has a 30-second timeout and some credentials. We can imagine this is a small present, and we could bundle it up with a shorter timeout to create a new context object that from the outside appears to only have that shorter timeout and those same credentials. But under the hood, the credentials are inherited from the parent, but the shorter timeout is sort of bundled in at the latest layer. And you can do the exact same thing with keys and values. You bundle it up with a new key and value called, let's just say, request ID and some UUID. Then this new context object will inherit the timeout and the credentials, but also have a request ID that can be looked up. We can take this further. We can bundle this with a new key value pair for where we overwrite the credentials key with a new value. So this output context will appear to have a different credential, as well as inherit the request ID and the timeout. But again, under the hood, the old credential still exists. It just can't be looked up anymore because it's been overwritten. And these are all still just pointing to their parents. And this sort of parent referencing, again, forces this tree behavior. Every context is built off its parent, and it can't modify its parent. And therefore, you can't like do that sort of backwards, I want to extend my timeout, or I want to cancel my siblings. So you can, all of these context objects from for each sub request are sort of like a bundled up version of a previous context object. So if we look at that API one more time, we've got our context interface, which I showed you, as well as those 2 possible errors it can return. But we've got 4 more functions at the top in the package, in the context package, with cancel, with deadline, with timeout, and with value. These are how we make and change our contexts. You can see all 4 of them take parents. All 4 of them output brand new contexts, and 2 of them take new timeouts. 1 of them takes new key value pairs, and 3 of them return cancel functions that you can optionally call to mark this new context as canceled whenever you want. So for any given sub request, if you wanted a cancel function so that you can cancel it on demand, you call with cancel. If you wanted to add some time constraints, shorten the timeout, you call either with deadline or with timeout, or if you want to attach some new key value pairs, a new identity, a new sort of request ID or something, you call with value. And that's how you can build out these sort of nested boxes. You create a context object that contains whatever you want. You just keep chaining these together. So the last thing about the package I want to talk about is background and to-do. You probably realized the chicken and egg of these 4 functions, which is they all require a parent. So what if you don't have a parent? What if you're not past one, or you're creating a request totally from scratch? Sort of the origin of all contexts are background and to-do. If you don't have a context object, you use one of those 2. So if we look at that API one last time, you've got our package context, those 4 functions, our context interface, and there's the 2 final functions are background and to-do, and you can see that they both just return a context. No error, no questions asked. They return a non-nil empty context. It is never canceled, has no values, and has no deadline. So this is just a reliable context that's just ready to go. It's never going to be marked as canceled. You can build off it however you want. And this is the 100% complete context package, at least of making this talk. Like, this is the entire package. These are all the functions and everything they do. So real quick, what's the difference between background and to-do? They both return a non-nil empty context. They seem to be pretty identical, and they basically are. Background, you want to use it by the main function, initialization, and tests. It's the top level context for incoming requests. So basically, when you need to create a brand new request from scratch, use background. To-do is when it's either unclear, you're confused, or a context is not yet available. Like the surrounding infrastructure is supposed to pass you a context, but it's maybe not ready yet. I don't know. It's just to imply to developers reading your code that eventually we'll replace this with a real context object. But for now, we're using a blank one. Functionally, though, they're nearly identical. I thought I'd point out the actual functional differences between the 2. If you look at the context Go code, they are both created in the exact same way. They use this local empty context type, and they just get immediately returned. So functionally, they look identical. The only difference is in the print statement on the string function. One will print as context.background, and the other will print as context.to-do. But there's no other functional difference, so it'll just print slightly differently in your logs. Okay, that was the end of that section. We're going to move on to the last section, which is just a bunch of usage patterns, hopefully some stuff you recognize, hopefully some inspires you to use them in interesting ways in your own code or in your own microservices. Usage patterns. So we're going to start with the cancel function, which is you should always defer a returned cancel function. You read the comments for the with cancel, it always tells you to defer a return cancel function. And why is that? So let's say in this request, we are going to make a sub request. We're going to add a 30-second timeout. This function returns a cancel function. And what you should always do is call defer cancel at the end, right after you get this cancel function. And why is that? Well, what if request errors out for something unrelated? We spin off a bunch of sub requests using this 30-second timeout, and then we have to exit early because of some error, some nil check, whatever. Deferring cancel ensures that we at least inform all those sub requests that we don't care about their sub requests anymore. Your parent has messed up. Your parent has exited early. Please stop working. We don't care about your request. So it's just for like clean code, keeping things simple. Similarly, if you already have code that makes a bunch of sub requests or one sub request using the same context, it's not a terrible idea to create a sub context with just a cancel, with just a dot with cancel, and defer that cancellation, just in case. Again, if sub request is relevant after this function returns, it's good to call cancel and clean up resources if we're going to exit early. Okay, so that's one pro tip. Another one is getting the deadline. Again, you can just call .deadline on a context object to get the timeout or the deadline. If OK is true, then we have a defined deadline. We can do math with it. We can count how many milliseconds until the deadline expires. Similarly, we can shorten the deadline by getting that deadline in the same way, but doing some math, subtracting some arbitrary amount of time, in this case, 200 milliseconds, creating a subcontext with that shorter timeout, and of course, calling defer cancel with the return cancel function. And then we can make sub requests using this shortened deadline. I've seen this pattern a bunch in some Google code. It's a nice little pattern where you can ensure that you have at least a little bit of time at the end. Even if these requests all time out, you have a little bit of time at the end to clean up some database, something, or yada yada. You can do some cleanup code, free up resources, whatever you got to do. Values, setting and getting. So you can call context.WithValue. You pass it a key such as this magic string request ID, and you could pass it some new UUID, whatever. And later on, you could look it up with context.value, passing that same key. Pretty straightforward. You know, you can print that we completed the request for this ID, and the values are just passed around sort of automatically stored within the context object. You can see here that there's a duplicate magic key string that I wrote up called request ID. What you frequently will want to do is put these keys in consts, some sort of type safe, hard to typo key name. So in this case, I have an ID key const, and I reuse that for the same function. So it's moved to a common const and reused. Here's a toy example of how an authorization check might occur. So let's say we're an authorization engine, or we're like a sort of IAM server, and we are passed a context and we're told, is this person authorized? Or can you tell me if this person is authorized? So the first thing we do is default it to false, and then we want to extract out the credentials using whatever credentials sort of keys and values they have. And there's a lot of pseudocode here, but we would pull out the credentials value. We would parse that it's like a valid object, that it's not nil. If all that's true, we could call is allowed, which could maybe do some ACL check against an allowed database or an allowed file, who knows, right? Again, a toy example. And if all of these checks pass, we would set allowed to true, and then we could return that to the user, or if not, return a permission denied error. This is sort of, obviously in real production systems, a lot more complicated and robust than this, but this is a toy example of how you would extract out credentials from requests, from context objects, and use them in apples, use them to authorize. So building off that, we can take a common package. We can build a common package using these two concepts from the last two slides, which is we can create a package called an auth library, let's say, use a common package safe key, such as creds, with its own type. And then we could have a set credential function that writes the credential by basically calling context.WithValue, returning a brand new context. And we could also have a get credential function that would extract out that credential and return if it was valid, or return a valid object if it existed, or nil if it didn't. And this is how a lot of auth libraries are built out in Go, is they sort of have magic keys inside the live package that kind of bundle up and extract out credentials for your authorization checks or authentication checks. So it's a common package imported by both the client and the server, so you can reuse it on your whole stack, and type safe private keys called by clients to add the credentials to the RPC context. And then this could be called by servers to retrieve those credentials from the RPC context and do stuff with it. So the last thing I want to talk about is just the done function. The way you might reasonably listen to the done function, since it's just a channel that hangs until the context is finished, is you make another channel for like marking your own work is done. You spin off your own work in its own Go function, which pushes a value to work done. And then you can use those fancy Golang select statements to pull from both your own work channel, which says like, I finished all the work I needed to do, or the context.done channel, which says this RPC is canceled, we don't care anymore. And whichever one of those finishes first, you'll return that error, which could be nil, sort of marking this request as completed. So basically, it's doing two things in parallel. It's doing the work of this RPC. It's also listening and waiting for this context to be canceled, whichever of the two finishes first. So this is a common pattern that I've seen in a bunch of libraries. So there's also packages that help with this, such as error group, which a lot of these helper packages have native support for context objects. So error group has a with context like creator or instantiator, which will give you a new error group that automatically listens for the done function. And then you can just use this error group to go spin off sub requests and call the blocking function wait. There's a ton of cool libraries like this. I like error group. It was recommended by the context devs when I was talking to them. So that will return nil if everything works happily, or an error if the context expired or something went wrong in your own work code. So if you were to pull from the talk context.done, you'd see that the channel is now closed, and we can print the line questions. So that's the talk, kind of long. It's about 30 minutes or 28 minutes. So appreciate your patience listening in, and let me just speak up if you have questions. There's an appendix. I guess you can screenshot this. Well, these aren't. You can just Google all of these. These are all public docs from like the Go blog. But I hope you all enjoyed it. I hope you at least learned something. I'm by no means a super duper expert. I don't work on context. I'm just a random engineer who works in Go who thought this was an interesting topic to turn into slides. So there might be questions I don't have the answer to. There certainly was at GopherCon, and it was kind of embarrassing, I guess. I was getting lots of questions that I didn't have answers to, but whatever.
Are we opening for questions? Or
yes.
Okay.
Yes.
Thank you so much.
Right
Hey,
ahead,
Sam.
right ahead.
Thank you so much. This is like totally good, and the way you opened it up, actually, I am till like that, like 30 minutes before, I was using just context.to for everywhere, wherever the context was expected.
Yeah.
This is good. This is like kind of an eye opener, and I'm one of the developer who don't read the entire code on the Go package, the description. So
Yeah.
one question, there are a couple of questions. The one question is like, so when we say done on the child process, what is that happen? What is that actually kind of triggering back to the context.background, which was the original place where the context was getting created? What happens to that object?
So context objects, when we call done, calling done is just listening for a done status.
Right,
like,
right.
Even if your request finishes successfully, it won't automatically mark its context is done. Its context still can live on, even though its resources get freed on. The original background context will never ever be canceled. Like a background or to-do context, again, will never be canceled. There's no way to cancel it functionally. You don't ever have access to sort of, I don't know, just like a cancel function for it or a timeout for it. It's intentionally uncancelable. So the worst case is that your context will be canceled all the way up, right up next to the background or to-do. But I think the idea is like if your function finishes successfully, you don't have to like mark. That's what sort of deferring cancel is about. So you can at least tell your sub requests that we're done working, but it doesn't really matter. There's no point to like marking yourself as canceled. Does that make sense at all? Like the context won't automatically be canceled when an RPC completes correctly, but it also won't matter because the RPC completed correctly and no one's listening anymore. Does that make sense?
Yeah. So I'm just gonna walk through that again.
Yeah,
so
sure.
If there are like two different requests spanned up in a, like say in your front end, like, can you go back to the front end back end tree structure again for a minute, please?
Yeah, sure.
And can you share the slide as well?
Yeah. I sure can. Oh wait. Oh, I think I do have it shared.
There's meeting notes. Would it be helpful to put them in the
meeting notes?
Thank you, Sam.
I'm presenting from my internal Google account, but I think I have the slides also copied to an external, my private Google account, my private like Gmail. So I can share it from there. Obviously I can't. I don't know. There's weird legal crap. But here, let me share one more time. Close out all my private information here.
While Sam does that, I just wanted to let everyone know that I've launched 2 polls, and your feedback is extremely helpful to us as we go forward with the meetups every month. So if you could just take a couple of seconds to answer the polls. If you do not see them, please just drop the message in the chat. But everyone should have seen the polls pop up in their window. Thanks, Sam.
Yeah. When I do share this, there are a ton of this slide. This talk is more like 45 minutes long originally, and I cut out a lot of like clarifying statements. Like you can see this slide where I clarify that the tree is actually based off of a background context and stuff like that. But feel free to ask. Is this the slide you wanted to ask your question?
Yeah. So for example, when front-end 1 gets the work done fast, and front-end 2 is also like kind of requested parallelly by the load balancer, for example. And when we mark done to the channel, when we say like done to this the channel that is listening, so it automatically makes the front-end 2 to cancel its process, or
that is totally up to the load balancer's implementation. So the load balancer will be informed that front end finished, right? Because it's requested the front end return successfully. And then the load balancer can be like, okay, in what you're saying, the load balancer sent out 2 requests in parallel.
Right.
It's up to the load balancer to be like, am I still waiting on the second request? And then they can either cancel that, they can manually call the cancel function on that context for that second request, or just maybe they still care about it and they let it.
Okay, that makes sense.
There's nothing sort of automatically happening. There's no like control flow automatically happening in the library.
Okay,
it's
the
totally
package actually defines how you can use it, and it's totally up to us like how we want to do that.
Yeah, so you can use it, and it's that's why it's so simple, but you can like use it in flexible ways, right?
Right. Oh, thank you.
Yeah.
Thank you so much.
So yeah, I don't know if anybody has any questions. If anybody found these slides baffling and you didn't learn anything, I understand. It's okay. I talked really fast. But
I do have a question. I realize this may be slightly outside of your wheelhouse, but we're using gRPC Java, and we do use context. And I'm just curious how much of the usage patterns that you went over at the end are still applicable to how gRPC Java works.
I had this question in at GopherCon, and I don't actually know, because people were like, well, this seems very Go dependent, but what if our stack has all different languages, right?
Yeah.
And I don't know, honestly. Like I think gRPC, one of the pleasantries of gRPC is it will kind of automatically, like it'll do pleasant things like turn your HTTP headers into like context objects. And I think it kind of has all these translation layers between all the different languages. If you're working entirely in Go, this talk is accurate.
Yeah.
Hopefully the Java implementation is very similar, and you can.
I'm seeing a lot of the same things, so I'll reach out to Eric Anderson and see if he has any feedback. If you can post these slides.
Yeah, that'd be cool. Be very cool. You can expect the slides. I'll put them in the meeting notes within half an hour. I'll commit to that, because I need to figure out how to like get a good link for them and all that. Make sure privacy and everything is good. So, and then I'll let anyone with the link comment, and I'll try and address comments, or you all can self-regulate comments. It's up to you. And I do recommend going through the slides once they're in the link, because there are, like I said, there's a handful of removed slides that are kind of interesting. They talk about value lookup, which takes a few minutes. I don't have time. But you can see how it kind of like unwraps context to try and resolve values. And this is part of the reason why you can have multiple key value pairs with the same key in the context object, but only one is resolved, and why you can't just enumerate all of the key value pairs within a context object. It's kind of interesting. So,
Sam, if you want to save the file or as a PDF, I can also help you.
Yeah, here I can
generating.
Probably. Oh, I'm still in my. I'm still looking at my corporate one, so I'll send you a link with the. I should be able to just share it in the normal Google Docs way. If I stop presenting, I can get you a link here. I'll just do that now, actually. Let me get you all a link, and you can put it in the meeting notes. And
does anyone have any more questions for Sam?
Yeah, no more questions, then I'll just get these I'll get the slides to Alma quickly. You can review them if you want, use them as your own little note takers. But I recommend you go read through the package, because the way I wrote this doc is it's actually a very short, well-written package with a lot of interesting blog posts about it. It's rather easy to just read 30 paragraphs worth of text, turn it into cute drawings, and make it a slide deck. And that's basically what I did. And I learned a lot in that process. I recommend it to others.
Actually, Sam, if you don't mind, I've got one last quick question.
Yeah, what's up, Benjamin?
Context with respect to streams?
What do you mean?
gRPC call that's a stream.
A stream.
Taking a stream or returning a stream.
I don't know off the top of my head. I would imagine the stream, I haven't used the gRPC stream API much. I imagine the stream, if the context is canceled, the stream will stop. I don't know. I'm guessing. You're going to have to experiment. I don't know.
Yes, I mean, that statement is true. I wasn't sure what the actual question was, though.
I'm just curious. So I assume there's a way to get a context from a stream, and then I'm curious, for example, is it stopping the next item coming from the stream if you cancel, or is it canceling the entire thing? And if there's a place I can just go read the exact semantics for how these apply to streams, that's great.
Yeah, if you look up the Go doc for gRPC Go, you should be able to find some documentation you probably want to look at the server stream interface. There's a function that will return the context. For whatever reason, the actual service handlers don't receive the context as an argument. They receive a stream object, and then you call the context function on that to get the context. But in any case, that's the context that would include the headers, for instance. And then on the client side, obviously that's where you set the context. And then if you cancel the context that you use when you create the stream, then that would cancel the whole stream. In terms of like messages that were queued, I'm not completely sure actually whether cancellation would clear out all the buffers and tell the server like, hey, your stream was canceled immediately, or if you would have to actually drain the buffer of already received but not processed messages. But yeah, I mean, that's sort of just an inherent race, I think. So if you absolutely need to know, we can figure that out. But in general, it shouldn't matter.
Awesome, thank you.
Okay. Well, here is a copy of the talk. Anyone with the link has commenters. If you guys want to go skim through it, there's a bunch of hidden slides that you can review. And I hope you found it interesting. I guess I'm gonna get back to work. So thanks for this opportunity. This was fun. Thanks a ton.
Thank you, Sam. And thank you, everyone.
Yeah. See ya.